Hey everyone, in this video we're just going to go through how to use the calculator and the z-score formula to find the mean and standard deviation in normal distribution type questions. So I've just chosen a few questions from 16D in your textbook just to kind of give them as examples of what you would do. So remember, this is how you would, if you have to find the mean or standard deviation like we do in this question, then there are two steps you need to follow. So that's why we need to do this video. All right, so the weights of cats are normally distributed. All right, so remember when we see the phrase normal distribution, we draw a bell-shaped curve. All right, just to get started. It is known that 10% of cats weigh more than 1.8 kilos. So if we've got 10% weigh more than 1.8. So if your mean is in the middle, so basically that's splitting it in two. So we've got 50% on this side and 50% on this side. So obviously the 10% is going to be somewhere up here. All right, so that's going to be your 1.8 and this is your 10%, which is the same as 0.1 if we have to convert it to a decimal. And 15% of cats weigh less than 1.3. So that's going to be down this end and as a decimal 0.15. And that's going to be 1.35 kilos. Now we don't know what the mean is and what the standard deviation is. All right, so what's the mean and what's the standard deviation? So if you have to find the mean and the standard deviation, or one of them, then you need to use the z-score formula. So z is equal to your x value minus your mean over your standard deviation. Now, at this point, we've only got the x value, all right? So your x value is 1.35, and we can set up another equation. Let's do that in a different color. I won't do green, let's do purple. Z equals x minus the mean over standard deviation. So that would be this value here. All right, so we've got two unknowns, the mean and the standard deviation. So when you have two unknowns, you need two equations. Now you're probably thinking, well, we've got the x value. All right, so we can write z equals 1.35 minus your mean over your standard deviation. And then this one, we've got z equals 1.8 minus the mean over the standard deviation. Now the mean and the standard deviation are the same, but the z-score is different for both of them. So for this one, you would have a z-score, and for this one, you would have a z-score. You're like, but how do I calculate the z-score without knowing what the mean and the standard deviation are? And remember, the z-score is just your standard value. So when we're dealing with a z-score, we have a mean of 1 and a standard deviation of 3. Sorry, not standard deviation of 3, standard deviation. Oh my God, what am I doing? Silly Billy. A mean of 0 and a standard deviation of 1. Sorry, I'm thinking ahead. So if we've got 10% up here, in this section here, I know that that's going to be somewhere between 1 standard deviation and 2 standard deviations. And down the other end, it's going to be somewhere between -1 and -2 standard deviations from the mean. So to calculate what the z-score is, so the corresponding z value, so let's do 1.35 first of all. So on our calculator, we go to interactive, inverse, and then we want inverse normal. So if you ever want to find an x value or a z value, you're going to be using inverse normal. All right, so we use the other normal function if we want to find a probability. If we want to find an x value or a z value, we use inverse normal. Now we're going to do this, we'll do this end first. All right, so we'll do this end first. All right, so that's on the left, so our tail setting is the left. The probability there is 0.15. And then we're just going to use, because we're finding the z-score, we just leave the standard deviation as 1 and the mean is 0. All right, so your corresponding z value is -1.03, blah, blah, blah. And we know that's true because we already know it's got to be between -1 and -2. All right, I'm not going to write that on the page because it's going to take forever. But effectively what happens is it's going to go, let me just circle. All right, it's going to go here in this Z value. All right, so now we're going to calculate the Z value down the other end. So we go inverse normal again. All right, so this time we're at the right because we're down the right end. Our probability is 0.1, because remember it was 10%, and we're still finding the Z-score, so we're just leaving it as 1 and 0, and we get 1.28, which we expected. Remember, it's going to be between 1 and 2. So my Z values that I've just found are going to go, let me just do a different shape. So this 1.8 is this corresponding Z value here, and this 1.35 is this corresponding Z value here, which goes here. All right, so I'm going to set up my two equations on my calculator. So just solving two equations. So the first one, I'm going to drag that Z-score down. All right, is equal to x, oops, let's just set up our fraction, not x, sorry, 1.35 minus, I'm going to use x for the mean, over y, which is the standard deviation. And then we do the same thing, just a different z value and a different x value. What was that, 1.8? All right. And then you get your mean and your standard deviation. Now we would expect the mean to be between 1.35 and 1.8, which it is, 1.55, and your standard deviation is 0.19. So your mean is equal to 1.55 and the standard deviation was 0.19. So just remember, if you have to find the mean and the standard deviation, or one of them, either the mean or the standard deviation, you do need to find that Z value first by using inverse normal, and then you just solve for your mean or your standard deviation. If you have to do both, then you have to set up two equations. All right, so here's another question. So machine A is packaging bags of mints with a mean weight of 300 grams. I might highlight things as we go. So there's our mean. The bags are considered underweight if they weigh less than 295. It is observed that on average 5% of these bags are rejected as underweight. Assuming that the weights of the bags are normally distributed, find the standard deviation. So we've been given the mean, told us at the start here. So let's do a quick sketch of our standard deviation, not a standard deviation, our normal distribution. So the mean goes in the middle. So there it is, 300. And the bags are considered underweight if they weigh less than 295. And it is observed that 5% are underweight. So 295, and that's 0.05. And we have to find out what the standard deviation is. So using the Z-score again, so Z is equal to X minus the mean over the standard deviation. I'm going to calculate Z first by using inverse normal, and then I'm going to substitute everything in. All right, so interactive, inverse, inverse normal. All right, we're at the left side. Our probability is 0.05. And we're just finding the Z-score, so I leave the standard deviation as 1 and the mean as 0. All right, there it is. We expect it to be negative because it is below. All right, so we're going to have negative 1.64 is equal to 295 minus 300 over standard deviation. And then we can just solve for the standard deviation. All right, so if you want, you can solve it as an equation. So just dragging that down equals, and then 295 minus 300 is negative 5, so we can just type that straight in. And then over our standard deviation, which is what we're calculating, and then comma x. All right, so the standard deviation is 3.04. Alright, in the same factory, machine B is packaging bags of licorice. The bags from this machine are considered underweight if they weigh less than 340 grams. It is observed that on average 2% of the bags from machine B are rejected as underweight. Assuming that the weights are normally distributed with a standard deviation of 5 grams, find the mean. So this time we're pretty much doing the same thing. We're just finding the mean this time. So it's a normal distribution. I'm going to draw the same bell-shaped curve. Alright, so we've got a mean in the middle, which is what we're finding out. They're underweight if they're less than 340. So we'll just put 340 down here, and that's 2%, so as a decimal 0.02. And the standard deviation is 5. So we don't need to really draw that on our normal distribution, but we do need to calculate the z-score. So remember, we do the z doing inverse normal on our calculator. Alright, so inverse normal, come on. Alright, so it's down the left end. The probability was 2%, so 0.02. Alright, so there's our z value, and then we can just put that into our standard deviation, not our standard deviation, our z-score formula. So z is this, is equal to, oh, why is it doing, I want that, there we go. The x value, which was 340, minus the mean, so that's what we're solving for, over the standard deviation, and I can't remember what the standard deviation was, 5. Alright, and then we're just solving for x, so comma x. Alright, so the mean is 350.27. And we would expect it to be bigger than 340. And there we go. Alright, question 6, you're not finding the mean or the standard deviation, but I thought I would just do it anyway. So the marks of a large number of students in a statistics exam are normally distributed with a mean of 48 and a standard deviation of 15. Alright, so there's our normal distribution, mean right in the middle, standard deviation of 15. Now we don't really need to do that, let's just do one either side. So that's going to be 63, and then on the other side it's going to be 33. If the pass mark is 53, so we would expect 53 to be between the mean and one standard deviation above. So if we're looking for the percentage, we would expect less than 50% to pass. But we can do that on our calculator. So we just go to, this is just a normal. All right, so normal CDF. All right, our lower limit is 53. And my hot chips already. The upper limit is infinity. Come on. All right, this time we're not doing the standard normal. We've got our mean and our standard deviation. So our standard deviation is 15 and our mean is 48. All right, so our percentage, so we've got that as a probability. So we can just multiply it by 100. So 36.9%, which we expected. We did want something less than 50%. If 8% of the students gained an A on the exam by scoring a mark of at least C, find the value. So 8%, so if this grey area here is 36.9%, so you would expect 8% to be somewhere up here. All right, so this part here is 8%. As a decimal, it's 0.08. And this is your value of C. So we've got to work that out. And remember, when you're finding an X value or a Z value, we've got to use inverse normal. So interactive, inverse normal. So this time we're at the right end. Our probability is 0.08. And we do have to change the standard deviation and mean because we're finding the X value, not the Z value. All right, so your standard deviation was 15 and your mean is 48. So a pass mark, so C is equal to 69. Not a pass mark, sorry, to get an A, 69%. All right, that's all. Bye.